Alright, guys, welcome back to Math with Miss Murthy. I hope this is the second time's charm. I did a whole recording, lost my voice already, did a whole recording, and then realized it actually didn't record. Anyway, welcome back. This is lesson 8.3. I'm trying to speak as close to the microphone as possible, so hopefully you're able to hear me. Right. So this lesson is on the area of trapezoids. This begins on page 451 of your textbook. As usual, please pause and do the warm-up on your own. And also pause for the standards of mathematical content and practices. Alright, today's lesson we will use and find and use the area of trapezoids by composing and decomposing into other shapes. Now, what do we mean by composing? Composing means putting shapes together, and decomposing means to deconstruct, to take the shape and split it up into smaller shapes that we know. So we know a trapezoid is a quadrilateral with one pair of parallel sides. To find the area of a trapezoid, first we're going to decompose or break it down into triangles and a rectangle. And since we already know the formulas for areas of triangles and rectangles, we can find the areas of each smaller section and add them together. So let's take a look at this triangle, this trapezoid. As you can see by the dotted lines, it can be broken down into a rectangle and two triangles. Now, how do we know that the two triangles are congruent? Because they have the same size. Both of them have a height of 6 inches and a base of 4 inches. So step 1, we find the area of the rectangle, which is 9 times 6, because the area of rectangle is L times W. That gives us 54 square inches. Area of triangles, because the two triangles are congruent, we only need to find the area of one triangle. Area is half BH. Substitute the values, that gives us 12. We add it all together to get the area of the trapezoid, 78 square inches. Okay. Which is area of the rectangle, 54, area of triangle, and area of the other triangle. Okay. Now, how did decomposing the trapezoid help us determine the area? Well, because we could calculate the areas of triangles and rectangles, so we can separate the trapezoid into those polygons and determine the area of the trapezoid. Alright, so we're going to move on to our example 1. Let's decompose this trapezoid to find the area. Divide this. Now, I do not know if these triangles are congruent or not, right? So I'm going to divide this into, say, T1, rectangle R, and triangle T2. Now, how do I know the base of T1? I know this base for the rectangle is 7 inches, which means this side is also 7 inches. But given that this portion is 10, I can tell that this side of the triangle is 10 minus 7, which is 3 inches. So I know my two triangles are not congruent. So I'm going to find the area of each shape. Triangle T1, half BH, gives me 7.5 square inches. Rectangle is L times W, that gives me 35 square inches. Triangle T2, half BH, my base is 2, my height is 5, that gives me 5 square inches. And then I add all three numbers up to give me the area of 47.5 square inches. Now, is there another way we can decompose this trapezoid? Take a moment, think about it. So I believe we can decompose this trapezoid into two different types of triangles. I'll show you both over here and then we'll calculate one of those. We can decompose it into two triangles like this, or two triangles as shown with the white. In both cases, right, I'm going to erase this for a moment. In both cases, let's say this is T1, this is T2, area T1 plus area T2. Now area T1 is nothing but half BH, which is half. The base is 10 plus 2, 12 inches, times H. The height is nothing but the same, 5 inches. That gives me half of 12 times 5. That would be 6 times 5, which is 30 square inches. And area of T2 is, again, half BH, which is half. My base this time is 7 inches, times height is 5. So that's 35 by 2, or 17.5. So my area trapezoid equals 30 plus 17.5, which is equal to 47.5 square inches, which matches what we saw earlier. Alright, I want you to pause this and do this on your own. I'll share the solution in a moment. There we go, the trapezoid is 78.085 units square. Now we're going to find the area by composing. So far we did it by decomposing. We know two congruent trapezoids can be composed or combined to form a parallelogram. And we know the formula for area of a parallelogram, so we can use that. Let's try this. Now let's take this drawing of a trapezoid. We're going to duplicate it, or rather make a copy, identical copy, flip it around the horizontal axis. We flip it and combine it, align it like this second figure. This, if I look at the outside lines, gives me a parallelogram for which I know the area. Once I determine the area of the parallelogram, half of that will give me the area of the trapezoid. Right? So let's go back to our example where we have 8 units and 12 units as the two bases, and the height is 8 units. So I'm going to show you that in this figure over here, right? Let me label it. This height is 8, this side is 8, this side is 12. When I flip it over, I brought this base over here, 12, and by that same token, this height goes here, 12. So my base B equals 8 plus 12, which is 20. This is the base B for the parallelogram. So my area of parallelogram is BH, which is 20 times 8, which gives me 160 units square. The area of the trapezoid is going to be half of that, so that gives me 80 units square. Now, how can we use the concept of composing to find the area if we do not know the formula for the area of a trapezoid? We just spoke about it. By duplicating the trapezoid, flipping it and placing it beside the original, we create a parallelogram. We know the formula for area of a parallelogram, and that's how we find the area of the original trapezoid. Now we're going to find the formula for the area of a trapezoid. We can see that the base B1 is the shorter base, base B2 is the longer base, the height is h, right? So when we copy it, the sizes are the same. When we rotate it, you see that B2 goes to the other side, B1 comes to this side. So for the parallelogram, my base B equals B1 plus B2. So I'm going to use that. Area of parallelogram is BH, which is B1 plus B2 times h. Area of trapezoid is half of that. So half of B1 plus B2 times h. I use the commutative property to change the order. So that's nothing but half h times B1 plus B2. So that's my formula for area of a trapezoid. Or in other words, area of a trapezoid is 1/2 the product of the height and the sum of its bases. Okay. Now, let's find the area of the trapezoid. Let's look at example 2. This would be on page 400 and, let's see, 55 of your textbook. Okay. My two bases are 6 feet and 10 feet long. Let's see if I do this using two methods. Composing the trapezoid into a parallelogram. My parallelogram has a side of 16 feet. The area is 16 times 5. So the area of a trapezoid is 80 divided by 2, which is 40. Because 60, the way I got 80 was 16 times 5. Now let's use the formula. Half h times b1 plus b2. I know my height h is 5. b1 is 10, b2 is 6. Or you can change the order, right? Does the order matter? No. So I have half times 5 times 16, which is 40. So either way, we get the area of trapezoid as 40 square feet. Now I want you to take a moment and compare these two methods. What were the differences you observed? Now, composing the trapezoid into a parallelogram helps us visualize the relationship between those two polygons. But finding the area using the formula is a much more efficient method. I want you to pause this right here and do this check problem on your own. I'll share the solution in just a moment. The ego area of this trapezoid is 9 centimeters square. Example 3, we're going to take almost like a real life situation. This is the shape of Osceola County in Florida, which resembles a trapezoid. This is on page 456 of your book. We need to find the approximate area of this county. Why do we say it's approximate? Because as you can see, there are gaps in this trapezoid over here, right? Anyway, what measurements do we need? We need the height. We need the two bases. That's all we need. We substitute this in the formula. Half h times b1 plus b2. Our height h is 51. b1 and b2 are 48 and 16.4. If you substitute in the formula, you get an area of 1642.2 square miles. Remember, it's square miles in this case because your dimensions were in miles. Now, in this case, why do we see that one of the sides of the trapezoid is the height? Well, as you can see from this figure, the one of the trapezoid forms a right angle with both the bases. Therefore, the height is the same as the side of the trapezoid. Alright, pause this right here. Do this check problem on your own. I'll share the solution in a moment. I don't know if I told you this trivia in this video. I know I for sure did it when I first tried to record. Trivia for the day is cheetahs are the fastest animals with speeds of up to 75 miles per hour. But humans can sneeze faster than that. A human sneeze would win a speed contest because human sneezes can travel up to 100 miles per hour. Alright, moving on to page 457 of your book. We're going to find the area of the airplane wings, which is in the shape of a trapezoid. You can tell that the height is 16.5. The two bases are 4.5 and 6.3 feet. Again, I just put this into my formula. Half times 16.5 times 4.5 plus 6.3, which gives me 89.1 square feet. Alright, I want you to pause this right here. Look at this check problem. Look at the dimensions given to you in the diagram. And find the area of the table. There you go. The area of the table is 14.25 square feet. Alright. Actually, let's go back to this problem for a moment. I want you to think about this. We found the area was 89.1 square feet. What if you wanted to make a model that is 1/50th of the actual size of the plane? What would you do? Right? Think about this, and maybe we'll talk about this in class. All right, now we're going to put this all together to help us find the missing dimensions of a trapezoid. Okay, what formula are we going to use to solve this problem? Here you can see that I know the two bases, 12 feet and 15 feet. I do not know the height, but I know the area. So how am I going to do this? I know my area of trapezoid is equal to half h times b1 plus b2. Again, I substitute all the known values here. Area of my trapezoid is 108. That's equal to half. I don't know h, so I keep it as h times b1 plus b2. That gives me half h times 27. And which is, I could rewrite this as 27 by 2h. So if I were to cross multiply or solve, like multiply by 2 and divide by 27, I can tell h is 108 times 2 divide by 27. Now I know that both these numbers are divisible by 3. So when I divide by 3, I get 36 and 9. And I know that 36 is divisible by 9. Gives me 4. Therefore my h is 4 times 2, which is 8 feet. Don't forget the units, it's 8 feet. Now does the solution change depending on which value we chose for b1 and which we chose for b2? Would it change if I said my b1 is 15 and b2 is 12? No, it won't, because we are adding both. So the order and addition does not matter. Alright, I want you to pause this and do this check problem on your own. And the height of the missing dimension, the height of the yard is 6. The height of this trapezoid is 6 yards. Now I want us to do this apply problem. The parking lot shown is being repaved. The office manager budgeted $10,000 for the project. We told that asphalt for this parking lot costs $8.95 per square foot. Find the cost of asphalt to determine if the office manager budgeted enough money to complete the project. Now the shape I have here is an irregular shape. It's not the shape of a trapezoid. But can I decompose this? I can, right? So let me look at how I can decompose it. There's multiple ways that I could decompose it. Let's just say first I'm going to go off with this way, right? So I get my rectangle R and my trapezoid T. So area, I'm just going to call it PL for parking lot, is going to be equal to area R plus area T, right? Now area R is nothing but L times W, which is 15 times 42, which would be 426.30 square feet. Now my area trapezoid is nothing, is half h times b1 plus b2. Do I know my h? Yes, I do. That's 24 feet. Do I know b1? I know 35 feet. Do I know b2? No, what I know is this total length is 32 feet, but I also know that this length over here is 15 feet. Therefore, this has to be 32 minus 15 feet, which is 17 feet. So I can substitute that here. That gives me half times 24 times b1 is 35 plus b2 is 17. 24 divided by 2 gives me 12. So this is nothing but 12 times 52. So as to not confuse it with the decimal, I'm going to use the multiplication symbol. And I know 12 times 52 is 624 square feet. So my area PL is area R plus area T, which is 630 plus 624, which is equal to 1254 square feet. Right. Now, can I stop here? No, I can't stop here because what I need is to find out how much it costs. Right? So I'm going to go back here. My total asphalt cost equals area times rate, which is equal to 1254 times 8.95. Times 8.95. That gives me 11,223.3, which is greater than the 10,000 that was budgeted for this. Right? Therefore, we can say no. The project manager did not. Again, remember, we can't just stop at this point. We need to complete our problem. The question that was asked, the project manager did not budget sufficient or enough money for the project. Okay. Now I want you to take a moment and think about it. Can this problem be solved a different way? Right? I believe we can. So previously we divided the rectangle, the trapezoid, in this direction. How about if we divide it like this? What are all my dimensions? Do I know this total dimension? This base is now going to be 32 feet. Height is 24. Now this base for the trapezium is going to be 35, or rather, it's going to be 15, right, plus 35, which is equal to 50 feet. And do I know this dimension? Again, I can figure that out. I know that this height is 24 feet. I know that the total height is 42. So this dimension is going to be 42 minus 24, which is 18 feet. So I could just substitute these back into the formula. My area of rectangle, it's the area of parking lot, is area rectangle plus area trapezoid. Area rectangle is 15 times 18. That gives me 270 square feet. Area trapezoid is half times height, which is 24. Again, I didn't write the formula in the previous one, but please do write the formula anytime. That's half times 24 times B1 is 50 and B2 is 32. I know that I can divide 24 by 2 to give me 12. So this is equal to 12 times 82, which is 984 square feet. So my area of PL equals 270 plus 984, which gives me 1254 square feet, which is the same as what I calculated earlier. If you look here, I got 1254 square feet. All right, I want you to pause this right here, do this check problem on your own. And the solution here is given over here. And then we have the exit ticket, which I'll post on the Google Classroom. Alrighty, that's it for today. Ciao.